This concept check question is asking you to draw the Newman projection for the molecule shown, looking down the bond indicated with the arrow. I'll start this one by drawing the back carbon in black and placing the substituents on that carbon. On the top, we have an ethyl group, and on the bottom, the hydrogen is on the left, and the OH group is on the right when we're looking down the carbon-carbon bond indicated. Okay, then we'll draw the front carbon and its groups, and we'll draw them in blue here. There's a methyl group pointing down. There's a hydrogen pointing up and to the right, and a chlorine pointing up and to the left. This question asks you to draw the Newman projection for 2-methylhexane, looking down the carbon 3 to carbon 4 bond. I'll start by drawing the structure of 2-methylhexane, double checking my number of carbons and the position of my methyl group. Then I'll identify the carbon 3, carbon 4 bond and draw an arrow for myself to note that I'll be looking down that bond to draw the Newman projection. I like to reorient the structure to make the carbon 3, carbon 4 bond horizontal, but you don't have to. It just helps me visualize the Newman projection more easily. I also like to draw the groups on those 2 carbons with wedges and dashes. Again, this just helps me visualize the Newman projection more easily. I'll start with the back carbon and its groups. There's an ethyl group pointing down and 2 hydrogens pointing up to the left and right. Then the front carbon, there's an isopropyl group pointing up and 2 hydrogens pointing down to the left and right. Now we just need to make sure we've drawn the lowest energy conformation, which means we need a staggered conformation, which we have. But because we have 2 groups on 2 different carbons, we also want to make sure we've drawn the anti-conformation, the one in which the 2 groups are pointing 180 degrees from one another, which again we do have here. So what we've drawn is the Newman projection for the lowest energy conformation of 2-methylhexane looking down the carbon 3, carbon 4 bond. Here you're asked to draw the Newman projection for the lowest energy conformation of each of the molecules shown on the slide. We'll start with the structure on the left, and I'll look down the carbon-carbon bond from left to right. I'll draw the back carbon first and place my substituents on that carbon. We have a methyl group pointing down, an OH group pointing up and to the right, and a hydrogen pointing up and to the left. Then I'll draw the front carbon and its groups. There's a tert-butyl group pointing up, a hydrogen pointing down and to the right, and a chlorine pointing down and to the left. Now let's do the same for the structure on the right. Again, I'll draw the back carbon first, adding the substituents, a methyl group pointing down, an OH group pointing up and to the right, and a hydrogen pointing up and to the left. Then the front carbon. There's a chlorine pointing up, a hydrogen pointing down and to the left, a tert-butyl group pointing down and to the right. Then I'll look at the structures to see if what we've drawn is the lowest energy conformation. And here I don't have a lot to go off of, but I know that the tert-butyl is the biggest group, so I want to orient the molecule so that the tert-butyl is next to the smallest groups possible. So I'll rotate the front carbon counterclockwise and place the tert-butyl group between the hydrogen and the OH. I want to move it away from the methyl group, our other large group. And then what we see is that these 2 structures are the same. They were just oriented in different conformations as they were drawn in black. So the Newman projection for the lowest energy conformation of each of these structures should be the same. It is the same, and it's the Newman projection underlined in black here.